opportunities as far as the technology is concerned, because nanotechnology or nanomaterial processing is really tough. Now, I will give an answer in two types. First, nowadays government of India, within itself, as well as government of India in collaboration with government of some other reputed countries, is launching several programs for such type of training, wherein if you are having some innovative idea, then you can submit some proposal or something like that, and then government will give you funding for such a training. Okay. First thing. Second, the training is not so much difficult for the processing or the development of nanomaterials. Like earlier, there was only a concept of composites. Now, with some initialization, we have developed nanocomposites using that powder metal technique. How come? The technique is same, the people are same, the people who are working are also same, the technology is also same. Then what is there? There is a little bit change in the processing. What is the change in processing? We have optimized the hour of milling, which we used to do in a ball milling machine. You optimize the hour of milling, and then you will come to know what is the basic concept. Okay. I would like to thank Professor Sayyid Hassan Jafri Sahab and Professor Dr. Muhammad Parvez Sahab, Head Department of Mechanical Engineering, Aligarh University, for organizing this event in a very successful manner in such a short interval of time. This is really very vast thing, and it is very much appreciable, because organizing such a thing in very short interval is not a very easy job. So both of these superb academicians must be committed on this particular event. Thank you.
Thank you, Dr. Gupta. And with this, we come to the end of this morning decisions. I once again thank you, Dr. Gupta, also, and for others who have good participation. And of course, I will congratulate all the organizers, being headed by Dr. Parvez, for organizing such a grand event. And then, very important that I have just mentioned, the two very critical areas of mechanical engineering for the students who get what is supposed to, and I hope in future they will go on this way. With this, I thank you all, and organizers, if they have some announcement. Thank you.
Lunch, which is situated at ground floor workshop, and please proceed with your respective tokens. Okay. Once again, it's ground floor workshop. Okay. Thank you so much.
May I request Professor Muzammil from Aligarh Muslim University, Mechanical Engineering Department, from Industrial Engineering area, to please come and chair the session for this particular technical session, and he will be actually chairing the session for about 7 number of papers, and they will be comprising of both production and industrial and design areas papers. So Professor Muzammil, to give you a brief info about him, he is a learned personality, person who is having plenty of research papers in ergonomics area, and he is right now the backbone of industrial engineering at Aligarh Muslim University. His PhD is from AMU itself, and he has been in this area since so many years. He has represented AMU both in India and abroad, and he has a dearth of knowledge in ergonomics. So I welcome you, sir, here, and it's our pleasure. Despite the attendance, the low attendance here, we know that there are some other people who are going to join us. may we request you to please start the session and ask our delegates to start presenting their papers, because we do have the time limit, because at 3 o'clock we are going to start a valedictory session which will be chaired by Professor Zahid Hussain Zaidi, ex-VC, Royal Khan University. So, Professor Muzammil.
Hassan, I used to say him Harvard, and he is my most beloved, just as a son of mine. My senior, my teacher, Professor Rizvi is sitting here. With his permission, I'm starting this. I'm thankful to Al-Fala University. They have invited me here to chair the session. Whatever Khawar Saab has said, it is just because of Professor Rizvi Saab. He was the real motivator and the real teacher, the actual teacher, जिसको आप teacher कह सके, he is that type of personality. And he has given me a lot of training, guidance, and what the research is, actually he has told me that how the research is carried out, how can you move in that direction, etc. I have worked in the area of ergonomics, did my PhD under the supervision of Professor Rizvi in Aligarh, and then kept working in that area. I am a co-author of the book. Again, I am there as a co-author in that book with the blessing of Professor Rizvi. He has motivated me there. We have a good research lab in the mechanical engineering department at Aligarh University, Aligarh, that has been developed to ergonomic research division. We have carried out various researches there. Some of the notable researches, you can say that we have developed a device for the control of Parkinson's disease. Tool design or product design has been a remarkable area for that. In the drilling machine, the way of drilling which is there, it is since last more than 100 years or so. We have developed a system with which the productivity has been enhanced up to 200% and with absolutely no fatigue as far as the worker is concerned. In the morning we were talking about sustainability in the session, in the inaugural session of your conference. In the area of sustainability, the Department of Mechanical Engineering has developed a shovel, that shovel which is made of bamboo mats. Bamboo mat board shovel has been developed and that is working well, and it is comparable with the performance of the conventional shovel made up of steel, etc. So a lot of work is being carried out in this area, and we are having a good team here. Anybody who is interested in that field is welcome here. Now I am coming to the business. We are going to start this session. In this session, we are having the papers related to the design and production engineering. So I am going to invite Mr. Furqan, Mr. Al-Fala from Iraq. The topic is manufacturing, design and structural analysis of a custom ankle board orthosis for food drop potential using 3D scan. Presentation, and 2 to 5 minutes will be given for question and answers, and please, you have to stick to the time. Thank you.
I'm scholar student in Aligarh University in mechanical engineering. I'm the supervisor for last year. I'm here presenting my paper for manufacture, design, and structural analysis of a custom and food dynamic AFO from composite material like carbon fiber. Number 3 is different from the other because there is hinge. It's articulated AFO, so it's different from the other types. The objectives, the main objectives of this work is to manufacture and design and analysis of the food orifices. The work is divided into two options. The main part is thermal and another is vertical. Vertical by analysis by finite element. The food orifices, there are, we can see the parts of this food orifices. The first is the calf ligament and the main threads and ankle joints. There are 3 main parts of this food orifices. The first food orifices is an external device. That was to support and improve the walking for the patients, especially of the lower limb during the walking, and will provide structural, functional characteristics of the neuromuscular system. We can see here there are 2 types of ankle foot, custom ankle foot orthosis. One from conventional manufacturing, and another from additive manufacturing. There are 2 types of manufacturing. Actually, there are different types of materials for orifices. Material selection may be from thermoplastic like polypropylene, polyethylene, another from metal like aluminum, another from composite like carbon fiber, because carbon fiber was high weight and very strong, and another we can make fiber. Actually, AFO can be divided into 3 groups: passive ankle foot orifices, and semi-active ankle foot orifices, and active ankle foot orifices. The passive ankle foot orifices, passive AFO designs is different because they don't have any electronics in these types. And semi-active, we have hydraulic and another is active AFO designs have with electronics, circuit, and use of diagonals and regulations, with the clinical and laboratories. And then there are 2 types of foot orthosis to use. First is custom orthosis fit patients' body and better performance of the line of the shelf. Because we need to get about fit dimension. The purpose of this study is really to simulate a better functional costing and performance by measure the force with different deflections, or 3 different types of force. The custom AFO, I take 50 Newton and 250 Newtons and 550 Newtons. We can see on the slides. And we analyze it by finite element. Here we can see some collections about who use about AFO. We can see there in India, there are 10% people rising in India, and now I think 2 billion people that uses ankle foot orthosis. And some study in Michigan University in housing that we are seeing. We can see definitely on the review about the uses of